A, B, and C are integers. A to the 4 plus B to the 4 plus C to the 4 equal to 4,608. A plus B plus C equal to what? So, for solving this, we should pay attention to an important idea when we have power of 4. Let's consider for example, A, or any number, M. M to the 4. I want to analyze this. Case 1. If M is even, for example, M is 2Q. So M to the 4 is 16, or let me write 2Q to the power of 4, which will be 2 to the 4 times Q to the 4, which will be 16. Q to the 4, I consider Q to the 4 as K, 16K, multiple of 16. If M is even odd number, 2Q plus 1, then I can say, okay, M squared, I should use famous identity that the identity is what? If you have x plus y squared, it will be x squared plus 2xy plus y squared. Now here, M squared will be 2q plus 1 squared, which will be the first one squared, 4q squared plus 2 times first one times second one, 4q plus second one squared, 1. Now I can say it will be 4 times q squared plus q, I factor from 4 plus 1. We consider this one as r, it will be 4r plus 1. Can also prove it is, for example, 8z plus 1, but I don't need it here. Now I raise both sides to the power of 2. It will be m squared squared. I want to find m4. 4r plus 1 squared. Then m squared squared will be m to the 4. 4r plus 1 squared. Again, I use this identity. It will be 16r squared plus 2 times 4r times 1, 8r plus 1. Now, here, I think I should use a better thing here. Here I prove 4r plus 1, it is not right. But I should, for this one, I want to prove it is 16, for example, t plus 1. So here I should prove it is, for example, 8m plus 1. So let's do something. Let's erase this part, prove a more powerful thing. Q squared plus q. I factor from q, it will be q times q plus 1 plus 1. Q times q plus 1 is even number, because product of two consecutive numbers. If it is odd, it is even. If it is even, it is odd. One of them is even, one of them odd. So you can say it is, for example, 2 times s. So 4 times 2 times s, it will be 8s plus 1. Now, if we raise both sides to the power of 2, m squared will be 8s plus 1 squared. Now, I simplify, then m to the 4, this one. I use this identity. It will be 8s squared, 64s squared plus 2 times first one times second one, 16s plus 1. Now I can factor from 16. It will be 4s squared plus s plus 1. I can call this part t. So it will be 16t plus 1. So we conclude m to the 2 is m to the 4 equal to 16t plus 1. So if you have odd number, the remainder when divided by 16 is 1. If it is even number, it is 16. Now, for this part, I want to calculate the remainder of 4608 when divided by 16. Okay, let's divide 08 when divided by 16. It will be 302. 32, it will be 414, 140. Then you should place 8. 8 times 6, 48. We have 4. 8 times 1 plus 4. This. It will be 1, 2. Then with 8. Then we will see it is 8, and if you, it will be 1 to 8, and the remainder is 0. So, we can say, so let's prime factorize. I can say it's 16 times 288. So, let's, it is 16 times 288. You can also consider 288 is multiple of 4. It will be 4 times 72. And 72 is 8 times 9. So 4 times 8 is 9. So it will be 2 to the power of 4 plus 2, 6, plus 3, 9 times 9. Now let's write a to the 4 plus b to the 4 plus c to the 4 equal to 2 to the 9 times. So if you have odd numbers, the remainder of odd number when divided by 16 is 1. If one of them be odd, 1, 0, 0, it is not okay because the remainder here is 0. 1, 1, 0 is not good. 1, 1, 1 is 3 not good. The only possible case 0, 0, 0. So all of them should be even. So we can say A equal to 2A1, B equal to 2B1, C equal to 2C1. And if you replace 2A1 to the 4 plus 2B1 to the 4 plus 2C1 to the 4 equal 2 to the 9 times 9. Now, if we divide by 2 to the 4, divide both sides by 2 to the 4, A1 to the 4 plus B1 to the 4 plus C1 to the 4 will be 2 to the 5 times 9. In the same way, again, we consider. We know the remainder here is 0. If we have 1, 1, 1, all of them odd, impossible, 1, 1, 0, 2, impossible, 1, 0, 0. Possible, all of them should be even numbers. Why? Because of this part. Even number is 16q, the power of 4. Odd number is 16t plus 1. Okay. So we conclude again, all of them should be even. Now I can say, okay, A1, let's write with other color. A1 is 2A2, B1 is 2B2, C1 is 2, C2, and A1 to the 4 is 2A2 to the 4, plus 2B2 to the 4, plus 2C2 to the 4, equal to 2 to the 5 times 9. And if I divide both sides by 2 to the 4, then A2 to the 4 plus B2 to the 4 plus C2 to the 4 equal to 2 times 9, which is 18. Now here, because 18 is a small number, I check what numbers I can place. Without loss of generality, the problem says there are integers, but because we have only A4, B4, C4, I consider they are non-negative numbers. And at the end, also, I consider plus minus of the numbers we find. So we know these are non-negative numbers. The 4, 2 to the 4, 0 to the 4 is 0. Plus minus 1, or let's consider first plus. 1 to the 4 is 1. 2 to the 4 is 16. And 3 to the 4 is 81. Here it's not possible use. 216 is not also possible. So the only possible case is one of them 16. Other one should be 1. And it will be 18. So I consider without loss of generality, I consider A2, for example, equal to 2, B2, 1, C2, 1. Now I know A1 is twice A2 and A is twice A1. So A is 4 times A2. So A is 8, B is 4, C is 4. And if you check, you will see it works. Okay, you will see it works. It is our first answer. We can say fundamental answer. And you can consider all permutation and all signs. So let me check for you A8 on. But the problem says what? The problem wants A plus B plus C. Let's check. A, B, C, one answer, 844. Like permutation or arrangement is not important for A plus B plus. Only signs are important. So in this case, 8 plus 4 is 16. Now, if we consider negative 8, 4, 4, it will be negative. It will be 0. One of them negative. If this one is negative, then it will be 8. Two of them are negative, negative 8, negative 4, 4. It will be negative 8 if the two that are negative are these two. Again, it will be 0, which we had. And if three of them are negative, 8, negative 4, it will be negative 16. So A plus B plus C can be 0 plus minus 8 plus minus 16. And if you is this, if you want to solve similar problems, learn similar ideas and also other ideas in geometry, combinatorics, number theory, and algebra, you can send message to my number, WhatsApp number in the comments and description. Please don't forget to subscribe, turn on the bell, and like the video. Thanks. See you next time. Bye bye.